Hello everyone and welcome to Pepcoding. I hope you all are extremely good. So today in this video we are going to discuss the solution of our next question, that is the brick wall, right? So let's first discuss the question and then we will move to the approach, right? So in this question we are given a rectangular wall of bricks, right? So all these bricks are of different width, but the height of all these bricks are same, right? So this brick is of width 1, this brick is of width 2, this brick is also of width 2, this brick is of width 1, right? So all these bricks are of different width, but the height of all these bricks is same, right? Bricks is same. So our task is to, we have to draw a vertical line, right? So in this wall we have to draw a vertical line in such a way that we should have minimum number of brick rows, right? Now a brick rows is that if the line is not passing through these splits, now in between two bricks there is some split, this is the split, this is the split, this is the split, right? So if the line is not crossing through that split, it means it is a brick wall. Now the line is going through the split, the line is not going through the split, so this is a brick wall. The line is going through the split, the line is going through the split. This means these lines have a total of 2 brick rows, right? So if the line is passing through the bricks, it means it is a brick rows, right? So our task is to find a vertical line, right? To find a vertical line such that that line should have the minimum number of this brick rows, and we have to return these, how many, these number of brick rows, right? For example, in this example the minimum number of brick rows can be have by using this line, so we have to return 2, right? So we have to return the minimum number of brick rows that we can have by drawing a vertical line, right? So for example, but you can't choose the extreme position, the maximum width of this wall, right? So if this is the 1 2 3 4 4 5 6, right? So you can't choose 6. Why? Because always you will have the minimum number of brick rows here. Why? Because there are no bricks present here, right? So you can choose any point less than the maximum width of this rectangular wall, right? Also you can choose the decimal point, but we will not choose that. Why? We will discuss later on, right? So for example, this is this is our 1 coordinate, this is 2, this is 3, this is 4, this is 5, and this is 6. So we are given a matrix of this like a brick is present of length 1, then of 2, then also of 2, then of 1, right? So in row 0 the 4 bricks are present, first of length 1, then length 2, width 1, width 2, then again width 2, width 1, right? In the next row we are having a brick of length of width 1 2 3, right? 3, then 1, then 2, right? Next is 1 3 2, 1 3 2. Next is 2 4, right? 2 4. Next is 3 3 1 2, right? 3 1 2. Next is 1 3 1 1, 1 3 1 1, right? So let's discuss that. If I choose to draw a line at the first coordinate, right? Instead of 4 I am drawing the line at the first coordinate, right? So this is, instead I can write it over here that this is the first, this is the second, this is the third, this is fourth, this is fifth, and this is sixth. So we have to choose a point less than the maximum length, right? So the maximum length of this wall is 6, so we have to choose a point less than 6, right? You can also choose decimal point, right? So let's suppose I am choosing the coordinate 1. So here I am having this brick rows, this brick rows, this brick rows. So total I am having 3 brick rows, right? Next, let's suppose I am choosing 2, right? I am choosing a vertical line at 2. So I will have this brick rows, this brick rows, this brick rows, this and this. So I am having a total of 5 bricks rows, right? Next, let's suppose we are choosing 3, right? So let's suppose we are choosing 3. So we are having 1, 2, 3. So 3 brick crosses. So at 3 we are having 3 brick rows. Next at 4 we are having 1, 2. So 2 brick rows, right? So we are having 2 brick rows. Next at 5 we are having, if I draw a vertical line at 5, then we will have 1, 2 and 3. So 3 brick rows. So now you can see that the minimum brick rows are present at the coordinate 4, right? So at coordinate 4 the minimum brick rows present are 2, so you have to return 2 here. So the answer of this particular example is 2, right? So let's find how we can do this. Now if you choose to draw a vertical line at decimal point, for example I want to draw a vertical line at 1.5, then the line is something like this, right? Then you will have the maximum number of brick rows. You can see here that you will have 1, 2, 3, 4, 5, 6, right? Why? Because the splits are only present at the integer values, so there is no any advantage of choosing the decimal points. Why? Because when you choose decimal point you will always have the maximum number of brick rows, but we want here the minimum number of brick rows, so we will only choose the integer points, right? So now for solving this question, one point to note is that minimizing brick rows, right? So minimizing brick rows is equal to maximizing the split rows. Right? You can clearly see here that if I am minimizing the brick rows, then this is similar to I am maximizing the split crosses, right? Because only two values can be present, either I am crossing the brick or I am passing through the split, right? So if I am minimizing the brick crosses, this means that I am maximizing the split crosses. So you can see here that at 4 I am having a split cross of 2, right? At line 3 I am having a split cross of 1, 2, 3. Here I am having a split cross of 1, 2, right? Here I am having a split cross of 1, 2, 3 and 4. 4. Right? Here I am having a split cross of 1 only. Here 1, 2, 3. So here I am getting the maximum split cross. So this is the same point where I am getting the minimum brick cross. So maximum split, minimum brick, right? So minimizing the brick rows is similar to maximizing the split cross, right? So we will maximize the split cross, then we will find our minimized brick rows, right? So how we can maximize we can find the maximum number of split crosses? We will use the prefix sum. Right? Now if I am able to find the maximum number of split cross, for example at 4th point I am able to find that the total number of split crosses present are 4, right? So 1, 2, 3, 4. So total number of split crosses present are 4. Now it is quite easy to find the number of brick crosses. How? That the length of this wall, that is 0, 1, 2, 3, 4, 5, that is 6 minus the number of split crosses, that is 4. So this is equal to my number of brick crosses. So this is my answer, right? So we will find what the maximum number of split crosses. How? By using the prefix sum. Then we will find the minimum number of brick crosses by subtracting the split cross from the total length. So this is my first point, this is second, this is third, this is fourth, this is fifth, right? So how we will find the maximum number of split cross? We are going to use a hash map. So this hash map will be of integer and integer. At the key value we are going to store these coordinates, right? So we are going to store this n, let's name this n, and at the value side we are going to store the splits. that is the number of splits, right? So for example, let's do this for this particular example only. Let's move to, we first move to the first row, right? So first row, in the first row I am having a split at 1, right? So after at 1 I will store in the hash map that at 1 I am having a split of 1, right? Now after 1, this is next split is at 1 plus 2 3. So at 3 I am having a split. So I will store in the hash map that at 3 I am having a split. Next split is at 3 plus 2 5. So at 5 I am having a split, right? So at 5 I am having a split, right? So now you can see that in the first row I am having a split at 1, at 3 and at 5, right? So next split is at 5 plus 1 6, but we will not consider the maximum value, right? Why? Because then the answer would be surely be here. Why? Because there are no bricks present here, so we are only going up to here, so we are not considering the last value, right? We are not considering the last value. Next we move to the row number second. At row number second I am having a split at 3, right? So 0 plus 3 3, so I am having a split at 3. Here splits, here split. So at 3 I am having a split. So at 3 now I am having 2 splits. So you can see that at row number 1 I am having 2 splits at 3, right? Next is I am having a split at 3 plus 1 4. So at 4 I am having a split. So I am having one split up till now at 4. Next is 4 plus 2 6, but we are not considering the last values, right? So we are not considering the last values. Next is at the next row I am having a split at 1, right? At 1, so now I am having 2 splits at 1. Next 1 plus 3 4, so 2 at 4. Next we are not considering the last point. Now after at 4 also, right? Next after at row number 4 I am having a split after 2. So I am having a split at 2. So at 2 I am having one split up till now. Next is at 6, but we are not considering that. Next at row number 5 I am having a split at 3, right? So 0 plus 3 3. So at 3 I am having one more split. At now next split is at 3 plus 1 4, right? So 3 plus 1 4. So 4 I am having one more split. Now next we are not considering the extreme value. Next I am having split at 1. So I am having one more split at 1. Next split is at 3 plus 1 4. So at 4 I am having one more split. Next split is at 4 plus 1 5. So at 5 I am having one more split, right? Next we are not considering the extreme value. Now you can see that the maximum split is at 0.4. This means that the minimum brick rows will be at 0.4, right? So you can see that at 4 or at 0.4 you will have the maximum split rows. This means that you will have the minimum brick rows at point number 4. And how will you find the minimum brick rows? Total length of this wall minus the maximum split rows, that is 4, and you will get the minimum number of brick rows, right? Brick rows, that is 2. So 2 will be your answer. Now you can verify from here that in the hash map you can verify that at 1 you are having 3 splits. So at 1.1 you are having 3 split rows. At 3 you are having 3 split rows. So at 3 you are having 3 split rows. At 5 you are having 2. At 5 you are having 2. This and this. At 4 you are having 4. At 4 you are having 4 split rows. At 2 you are having 1 split rows, right? So by using this hash map you are able to find the prefix sum. By using prefix sum you are able to find the maximum split rows, and from that you are able to find the minimum brick rows, right? So this is the approach of this question. Now let's try to code this. So firstly we are taking a hash map of type integer and integer. So both the keys and values are of type integer. Let's name the sets map new hash map, right? Next we are doing what? We are moving in these rows, right? So let's move. In order to move in this row we are given a list of list, right? So for let's use for each loop list of the name of the list of list is wall. Next, at each row we are taking a prefix sum. Firstly the value is 0, next we are adding 1 to it, next we are adding 2 to it, next we are adding 3 to this, right? So firstly we are taking a prefix sum as 0. Next we are moving in these columns, right? We start moving in these values, right? So let's move in these values. Now why I am taking -1 here? Because I am not taking the extreme value. Why? Because when I will take the extreme value, I will move here, that is at the maximum value, but I don't want that. That is why I am taking -1 here, right? So we are taking the value list dot get I, right? Now add this value to the prefix sum, right? Next we are doing what? That after adding this value we are putting this value in our hash map and also increasing the value of this particular coordinate, right? So in the map put the value of prefix sum, and if the value is already present there we are incrementing the value, right? But if the value is not present we are initializing it to 1. So we can do what? Map dot get or default. So if the value is already present then add 1 to it, otherwise take the default value as 0 and add 1 to it. So you will get the value as 0 plus 1 1. So first time, for the very first time when I am moving here, so the default value is 0, so 0 plus 1 is 1. I am getting 1 here, right? So the default value is 0, otherwise whatever value is present, whatever the number of splits present, add 1 to that split. Next we have to choose the maximum of this. So let's take a maximum variable here. Initialize it to 0. So always maximize this value of the split cross, right? So whatever with the max variable and the value for that particular point, that is the prefix sum, right? And in the end, after moving through all these points, we are returning the total number of walls, that is the total number of rows in this minus the maximum split we got, right? So the total number of wall we can get from wall dot size minus the max, that is the maximum split cross we got, right? So let's try to run this. So the test cases for this particular problem are not being updated on this portal, so we will update that soon. So this particular test case is the same example we have taken here. So the answer for this is 2. So we are getting the correct answer. This means that our code is perfectly correct, right? So you can try this code. We will update the test cases soon, right? So we are taking what? That we are taking a hash map and we are maximizing the split cross. From that we are getting the minimized brick cross, right? So in the hash map we are using the prefix sum, right? So I hope the problem is clear to you. So if the problem is clear to you, then give a like to this video. We'll meet in the next video. Till then, bye bye, take care.